Welcome, Christine Shayim. We're so happy to see you today. I know Kevin had the chance to meet you. This is my first time getting to know you, but for our listeners, kind of share a little bit about who you are and how you came to be involved in space.
Yeah, so hi, glad to be here. So my name is Christine Shayim. I'm a junior at the University at Buffalo. I'm studying computer engineering with a minor in mathematics. But mainly my interest is in aerospace, as you know. So at the lab I work at, it's the University at Buffalo Nanosatellite Laboratory. I am the project manager and the flight software lead for one of our projects for Polar. And yeah, so even though like aerospace isn't directly related to my major, it's not directly related to my major, I still found an interest in it because there still is a lot of software engineering, computer engineering sort of elements that go into that. So I'm glad I can apply my skills to a unique field such as this.
Tell me what a project manager does in your role there in the lab.
Yeah. So the project manager's main duties are to basically just keep everyone on schedule and um, just to sort of get a gauge for how long tasks will take. So, for example, I guess a good example of a task is create a trade study for a component. So this is a task, right? But a lot of elements go into that task, like researching what the market looks like for that product, researching, um, you have to know what the requirements are for what you need, basically. So you take this task, you decompose it into smaller tasks, and then you basically add up the times that you think
Like
those
a
tasks
Gantt
will take.
chart, right? You're kind of like making, or I've seen a tool like I used Asana before, which is like a scheduling tool, like what you're talking about, to help you break apart, and then you can work with teams to kind of see who's doing what parts, I guess. Because is it just one person doing the tasks, or multiple people working on several tasks to lead to that larger one, right?
It would definitely be multiple people working on that task, and that goes to the next duty of a project manager is to manage the personnel that we have. So um, like different tasks, it's obviously going to take different levels of effort, different levels of collaboration. So it's also the duty of the project manager to make sure that the personnel is properly distributed over those tasks, just like what you said.
Are you guys currently working on a cube satellite, or what is the project's larger mission that you're seeking to do?
Yeah. So I guess a little overview on POLAR. So POLAR stands for Polarimetric Observer Light Analyzing Research, which is a mouthful, but basically what our project is going to do is we're going to have a satellite in low Earth orbit, and our payload is a MEMS polarimeter. And basically what we're going to do is we're going to measure the polarization of light reflecting off of other objects in low Earth orbit. So and this is useful because different objects reflect light differently, so we can use the polarizations in order to differentiate objects. And then later down the line, once this science has been refined a bit, we'll be able to tell other like characteristics of these objects, like trajectory. If you can discern different materials of that object, you can discern its purpose, like maybe it's a satellite.
Is this related to remote sensing? Is that
It's all
similar? Oh,
remote
it is remote
sensing.
sensing.
Yeah.
Yes, definitely.
I'm excited when I can apply a term that I've learned. So forgive me. It's remote
Yeah, yeah.
sensing.
Yeah, that's basically our lab's main goal because we have another project named GLaDOS, which is a similar deal except they're using the glint off of objects in order to characterize their materials, but it's a similar process that they'd have to go through.
All
So
right.
that's basically our lab's main goal, like to improve space situational awareness using these qualities of light reflecting off of objects.
All right. I got to ask, what the heck is glint in terms of
Glint.
physics and optics? What is glint
Is it like a
versus
shimmer?
what is it versus a reflection?
Yeah, so glint versus reflection. So basically glints only happen, you can only view them from Earth during a certain period of the year. So basically the sunlight has to be reflecting off of this object in a very certain way, a very specific way, such that there's like a significant amount of light reflecting off of it in order for a visible light camera to be able to detect
Okay.
that light. yeah, the difference between that and just like the visible light around it. So it's like a specific kind of reflection, basically.
Wow. So
Mhm.
let me get this right. Your polar mission is going to look at reflected sunlight off of an object. Is it
Mhm.
the, let me ask this, what about warm bodies or objects that give off their own light? Does your technology apply to that, or is this something unrelated to, say, an object that's emitting visible
You mean
wavelengths
like
of
something
light?
living?
Or I'm thinking about something that's either warm, that would be infrared, or something like a, that's producing its own light.
Yeah, so as long as mainly our mission is going to focus off of the light reflecting off of objects, but as long as a source of light is polarized in some way, or maybe it's not polarized, and you can still discern the, I guess, the different wavelengths of light within that source, then you can still tell characteristics about what, what the where that light is coming from, the object that that light is coming from.
Right. Well, I'm
Mhm,
going to deep dive with you on two subjects today. This will be one.
mhm.
So for our listeners, polarization is really about, in a photon, how much the electric and magnetic fields are offset from each other. Is that a really low tech way to explain polarization?
Um, Sorry, can you repeat that? My bad.
So I'm trying to think of a way to explain polarization,
Mhm,
right? Where in my mind, you have the electric and magnetic fields oscillating at right angles. And if
mhm.
they are, if those peaks and troughs are off by degrees, you get various kinds of polarization, right?
Right, right.
Circular polarization or elliptical or whatever. That's about as deep as I can go. Can you help us understand polarization from your perspective, maybe in a way that maybe is more friendly for our listeners?
Or me?
Yeah, yeah. So polarization is exactly what you said. Within a source of light, there are different wavelengths of light within that source of light, if that makes sense. So maybe if you're looking at if you take the sun for example, the sun is a source of light, but then within that source of light, there are different wavelengths of visible light that also emit from the sun. So visible light, there's the different colors like red, orange, yellow, all of that. So within a source of light, a source of light is a combination of those different wavelengths,
So,
pretty much. Yeah.
so you're going to resolve incoming light reflected off a subject and obtain information about the identity of the object based on, I guess, having a library of, we know what uh, aluminum looks like, or a forest, or whatever. Is that sort of what we're hoping to do? Is you will identify objects,
Is it like spectrography too?
spectroscopy?
Spectroscopy.
Yeah, is that what you're hoping to do? And is this? Would you say this is fair to say it's a military application, or is it a commercial application, or is this just pure science?
So I guess going for your first point, like our goal is to use this science for material estimation. So like I said earlier, different objects, they would polarize the light differently. So that means that once you have a source of light reflecting off of that object, the you can sort of discern what characteristics of that object based on what wavelengths of light you can detect from the reflection, of course. And
Okay.
then yeah, and then for your second point, I guess there are a lot of applications for this. Um, yeah, there are a lot of applications. It could be commercial, it could be within the realm of defense. It could be for space, like I said, our goal is space situational awareness. So in the future, maybe if there's, too many objects up in space, there's a way to sort of sense if something's coming and, you know,
Move out of the
move away. Yeah.
Okay.
So in the future, that might become a technology that's needed.
What
Okay.
stage are you at in the production or the building of the satellite?
Yeah, yeah. So at this point, we're in the late design stage. So basically we have all of our components picked out. We have an overview of what our mission's going to look like. We have a rough mapping of what the phases of our mission from the ground to launch, post-launch, and then also deorbiting. We have a rough mapping of that. We have models drawn for the structure of our satellite. We have sort of, for each subsystem, we also have designs for that. So for example, I'm the flight software lead. So at this point, we do have a design of the software architecture, which in the future may or may not change, but it's important. What the important part right now is that we have the design mapped out. So then you can use that design in order to just basically work our way down from the application level to the functional level to lines of code.
Right. Do you guys use the NASA systems engineering sort of model for
Yes.
PDR, CDR, all of that? So is it safe to say you're between PDR and CDR, somewhere in there?
Yes, that's exactly right. Yeah, we had our PDR about it was last December, like early last December, and we have our CDR coming up this like late in November. So that's exactly like spot on. Yeah.
Okay. So for our listeners, PDR, preliminary design review. And we do that at my level, at our level with the middle and high school kids, we do PDRs as a requirement to apply for NASA's CSLI. And you're a much more robust sort of organization. You are going to go to your critical design review, CDR. And am I right? Once you pass your CDR, you're sort of locked in on your you're not going to tweak your designs much after that. You're sort of locked in. Is that right? Or can you make changes after your CDR?
Yeah, that's a good question. So for the most part, after CDR, your designs ideally should be finalized. But of course, in the engineering world, it doesn't always work out that way. But for the most part, your design at that point, your design is finalized. Then you go into the prototyping stage.
And do you already have a ride for your satellite?
No. So
So that's who
the
you're applying through CSLI, or how are you looking?
yeah, I can go into that a bit. So our lab, we're funded by the UNP, which is a branch of the AFRL. So basically, like,
Hold on, can't use acronyms in our lay
oh
audience.
yes, of
You
course,
gotta
yeah.
define the acronyms.
Okay, so the UNP is the University Nanosatellite Program, which is funded by the AFRL, the Air Force Research Laboratory. Yeah, so basically they every few years they select a group of university nanosatellite projects, and they give them funding to basically finalize their design. So we like our proposal for Polar was chosen, and then they gave us funding for designing, basically for our design and to procure our hardware for testing and all that. And then so after CDR, we have FSR, which is the flight selection review. So basically at this point, like if they decide that our design is robust enough, if they decide that our science would be a benefit to our customer, then at that point we go on to what's called phase B, where you actually begin prototyping. You begin to dive more deeply into your mission science to make sure it's feasible, and you get more funding in order to do so. So yeah, and then at that point, and then after that, like we would also they'd also help us find a launch provider as well.
So UNP, as I understand it, you compete and you are selected, and I think it's probably like what, 8 to 12 universities a year.
Yes,
It's a very select group, and then you move along the pipeline, and as you successfully complete a task, then they fund you, or you're promoted to the next level. But the eventual goal is that you'll be funded all the way to operational phase and launch, right?
Yes,
That's
definitely.
actually a great idea to hear your deliverables, and once you achieve them, then you get the money. That makes really good sense, instead of just saying, hey, good luck getting the money, or we're just not going to give you a chance because you don't have.
Yeah, I might have I might have cheated there a little. Jose Nunez, who runs, I guess, the UMP program at KSC, he spoke at our conference last year. So I love the UMP program, and I'm really glad, I'll gladly support any university that needs like a broader impact with like a K-12 audience with our CubeSat kids. So yeah, that's number one. That's great that you guys were selected. But let's be honest, Dr. Crucides, he's a pretty well-known guy in the world of small
Yes,
sats
yeah.
and CubeSats, and um, which brings me back to another question. You had mentioned SSA, space situational awareness. I was wondering, sometimes we hear SDA versus SSA, space domain awareness versus space situational awareness. What's the difference? Is there a difference? Are those words interchangeable? What's your thoughts on that?
At least from what I understand, space domain awareness is just an awareness of your environment in general, but then space situational awareness is not only your environment, but taking into account what your satellite is aiming to do as well. So like for our lab, for example, we would have to be aware of, where our targets are, where like, other satellites might be, but then we also, once we seek out our target, we'd have to there's another layer to that. Like when you're seeking out your target, you have to like be aware of the trajectory of your target, but then you also have to be aware of your own trajectory. So there's a sort of like another layer to it.
This is very interesting. The way you're speaking, you speak as if you have a military job. You are using the vernacular of, I was in the military for a while. Are you, for instance, is your lab, because you're funded by AFRL, do you have any restrictions like I can only have American citizens working in the lab?
Like
Or
ITAR.
is your lab, yeah, with ITAR restrictions, or is your lab sort of have this black curtain where the citizens work on one side, but you can have other students working on aerospace projects in the lab, but not on, say, Polar? How does that work at UB?
Yeah, so our lab, we do adhere to ITAR restrictions just because of the nature of our funding. We work with the government, so uh, it's not a requirement by the UNP, but just because we work with the government, just because our PI, he has a lot of, connections and business in high places. We just adhere to ITAR restrictions just to, be safe.
And I know I used ITAR first, but for our listeners, ITAR is International Trafficking and Arms Reduction. And the US Senate has, I guess, the government has passed these rules about the way that we are not allowed to transfer technologies to non-US citizens. I think we work probably closely with our allies, but there are certain things that we're not supposed to
Or
share.
like trade secrets, so they
Yeah,
could get
and in fact,
advancements.
the government for a long time was slow to adjust the language. So for a long time, it was anything to do with satellites. And the irony is you can go on the internet and buy all the satellite parts you want from all these other countries, but there are restrictions about what we can share and do and, for instance, sell. And I guess you're aligned with defense, would you say it's fair to say that you will see more of these, I guess, constraints about who you work with, who works in your lab, things like that? Is that fair?
Yeah, yeah. It really all depends on just the nature of your work and what you're aiming to do. So, for example, our work could be applied to defense and military. Um, so it is valuable. It's very important that we do keep
Mhm.
like prevent exports from happening with our knowledge. But like you said, anyone could buy satellite parts online if you have the funding. But I guess what's unique about our mission is the science behind it. That's what's
Right.
important. That's what we have to protect.
So one day when you were 5 years old, did you just say, I'm going to grow up and do computer programming for satellites? How did that start?
It definitely did not go like that. I can't say. Um, when I was younger, I wanted to be everything basically. I was interested in everything. Like I just found an interest in everything. Like I wanted to be a doctor at one point. I wanted to be a real estate agent or a surgeon, whatever. But I guess like I guess technology and science was really what called to me in the end. Um, so, but of course, like within science and technology, there's still a lot of branches, a lot of different fields you can go into. So a lot of me figuring out where I wanted to go was just trying out new things. Like in high school, I was very fortunate to go to a high school where STEM fields were very much like emphasized and people were pushed to go into that. So I was able to take engineering classes. I was able to take like electronics classes and just kind of dabble in basically everything. So I guess eventually I came to the conclusion I wanted to be an engineer because I liked creating things, I liked designing things. So, but then of course within engineering, there's also several different branches. I actually came into UB as a intending to be a mechanical engineer, and then but I just felt that computers kind of interested me more. So, I switched to CS, and then I realized like there's sort of like a something in between that. So I switched back again to computer engineering. So I guess the long and short of it is just a lot of just trying different things out, like seeing what I liked, what I didn't like, and then just like picking the best thing for me.
So kind of like adjusting, kind of like you're on a path, but you might have a little shift as you went to kind of like, oh, this may be this way. I mean,
Exactly.
that's smart to do. I want
Exactly.
to ask a question about project management before we get close to the end here.
Mhm.
I can imagine just working in groups in general, like you said, finding their skills, what they might be best applied towards, but it has to come with some challenges. So what are some of the biggest challenges you have working with diverse people trying to get this larger job done?
Yeah, so the biggest challenge I've come across is just um because we're all in college, like, the biggest challenge is just getting the work done and not asking the correct amount from people. Because if you ask too much, they're gonna get scared away. Too little, they won't be interested. So just like finding the sweet spot and also like working off of people's strengths. Um, I guess a big part of it is getting to know your team members and getting to know like what people's working styles are, what people's communication styles are, and just leveraging those elements of everyone to just get the job done in the end.
Yeah, I can imagine because we have some students who are in university level. My son is one of them, and he's trying to also work with a team. And it seems like they're oftentimes delayed just because of exactly what you said. They're in university. So that, I mean, that in and of itself is like a big consideration, right? And I like what you said about communication styles. I think that in any group, people may have skill sets that apply towards certain parts, but how well they communicate, are they more apt to answer in a text or in a some kind of an app where everybody's kind of working, or are they answering emails? Like you prefer emails, but our younger students do not really respond well to the emails. It's a challenge, so you have to meet them where they are.
Right. Right.
Exactly. Exactly.
My question to you is, or here's a question to you. I have two, but one is, you're a junior. What is Christine's ideal first job when she gets out of undergrad? Is it grad
Oh,
school or
goodness.
is it industry? What if you could just pick your job today, what does it look like?
If I could pick my job today, just anything kind of design related, anything that allows for creativity, anything that allows for just deviation from the norm in a good way. Just anything that allows you to sort of get your ideas out there and explore them, even if they don't end up working out. Just having any job where you're allowed, given the freedom to do that.
So
I don't.
you're an originalist, right? You just want to be
Yeah,
distinctive and original. It really doesn't. So that could mean maybe not even aerospace, right? It could be STEM, but not aerospace.
it
Oh,
could be. Yeah,
wow.
I very much am just keeping my options open. That's what I tell a lot of people. I'm a TA. That's what I tell my students. Um, to just keep your options open because you never know what opportunity might come, falling into your hands.
Right.
Mhm.
Well, I just want to say I'm so looking forward to the University of Buffalo contingent that's going to come to our conference next month. Are you coming also?
Yes, I will.
Yeah, she's got a poster she's presenting on.
Yeah.
On Polar,
Oh,
right?
I'm sorry, I forgot.
Yep.
Yes, Polar.
Yeah.
Do you know Chet? I guess you and Chet work together, right? In the
Yeah,
lab?
yeah. She's actually our kind of lab manager, basically. Yeah. So we
I
definitely
believe
work very closely together. Yeah.
I believe Chet's coming as well.
Mhm.
I'm really excited that you guys are coming because you were some of the most interesting people, young people I met at Small Set this year. So the fact that you're going to come to Florida and hang out with us, I'm really looking forward to our younger students meeting you so that I'm sort of this old guy, but you're like 8 years older than the kids are that we work with. So they will look up to you, and it's a great opportunity, I think, for you college kids to help point them, help them see what's just down the road for them. How I think fun it could be as they find their career paths as well.
Yeah, that's definitely one of my goals. Yes.
Well, we normally end with, some kind of words of wisdom or advice, and you kind of just shared that's what you share with your TAs. But as we close, if you do have any other words of advice you want to share, or if you want to point us in the direction of your satellite team's social media, where anybody who might be able to follow you could go, let's use this last few minutes to do that.
Yeah, so for our lab, I guess we have a LinkedIn page. It's just University of Buffalo Nanosatellite Laboratory. We have a website. It's called ubnl.space. There you can find contact info. You can find a little overview about our missions. And I guess closing out with words of wisdom is just like I said, like keep your doors open, like keep your viewpoint open because you never know what opportunities might come to you, and you never know what if your path might deviate from what you expect, and if that deviation will be better for you.
Yeah, it sounds like if somebody goes in thinking it's only one way to get to their destination, that probably wouldn't be as conducive as realizing there are multiple ways to still end up where you're going.
Exactly.
Thanks for sharing that with us,
Yeah.
Christine. We really appreciate you spending that time with us today.
I said it in Utah. I'll say it again. Thank you for spending some time with our students. And thank you for being with us today. And we are so looking forward to seeing you next month at Kennedy Space Center.
Yes, thank you for having me. Glad to be here.
All right.